to the Optimum CAD solution. I am Pankaj Ratnaparki. Once again will start our free online course, that is Plastic Product Design and Advance CATIA. Today we are moving towards our 20-second tutorial, that is plastic pump cover with the multi-outlets. So for today's task, we have the 2D reference. So this is our 2D drawing, and with respect to all the dimensions, we are going to convert this 2D into the 3D. So for the preview of our task, this is our isometric view. So without wasting the time, we'll start actual modeling in the CATIA. So here we're in the CATIA, we'll give the name as a tutorial 22, and as usual we'll start from the axis system. So first of all we'll take a origin point. I will just drag my all toolbars on the window. So here this is the default origin. So I will hide all the default planes, and before that we'll take the axis system, select the origin point and whatever the orientation. So as per currently we are just taking XYZ from the default planes. So we'll hide the default plane and we'll start for the designing. So this is our 2D drawing, and from that we'll start from this 100 mm. So the height is for after, then we'll thought about the height, but we'll start from 100 mm diameter. Select the plane, select the orientation as per requirement, enter into the sketcher toolbar and draw the circle of a 100 mm. So basically for this task we are using the surfaces. So we'll enter into the generative shape design. So here is the generative shape design. We'll enter it into that and we'll use the command extrude, and whatever the just we have some angle here, a draft angle, that's why we'll use the swept surface definition with the draft angle with respect to the direction. So here that command, so we'll select that particular sketch or entity, we'll give the 3-degree draft angle and we'll give the length, and direction is missed, so here is the third direction. So here is the preview. So we get extruded, that particular circle or the cylinder is get extruded with respect to the 3-degree of a draft, and after then we'll close that particular circle, will join everything, and here the basic cover cylindrical shape is get completed. So we'll apply the radius here with respect to that sharp edge. We'll give the 10 mm as a radius, and here the basic cover cylindrical shape in a surfacing get completed. So join all the surfaces for doing the close volume operation. So here the all surfaces are get joined and all are well connected. So now let's go into the mechanical design, part design, and we select the new body and we'll name it as a base body, base cylinder, and here we'll use the close volume command. So just here the solid get converted by using the close volume command. So now we are moving towards the top side outlet design. So in our cover there are the multi outlets. In that the top side is going to be, we are going to design. For that, select the sketch and we'll enter into the sketch modeling, and we'll draw the basic shape of our outlet, and this dimension is almost 60. So this is the 60 mm, and there is a 20, just we'll see the detail view, section view, and this will be the 24, that means radius is a 12 mm. So this notch is most important. We'll see the dimensions here, and this notch is of a 4 mm diameter and it is 7 mm away from the top side. So here the dimensions from the reference we are adding. So this angle is of a 30 degree. So this notch is important for holding the hose or a rubber pipe is coming on this outlet. So after completing this sketch, we are using the revolve command. So here the sketch is get completed. Okay. So this is the 60 mm, 7 mm, 12 mm and diameter 4. From this we'll confirm once again. So here get completed. But sketch is looking like not completely closed, so that will complete this one. Okay. So here the sketch is completed. So after finishing this sketch, we'll use the revolve command. Already we had taken the new body. So after this outlet, we are going to move towards the rib designing. So we are adding the ribs throughout the basic cylinder. As this is the plastic components, 2.5 mm wall thickness, so the ribs are important. So that we inserted a new body and we are entering into the sketch here. So here this one is the central rib. Firstly we'll design one rib and after then we'll use the pattern command. So this is the ribs. So for that select the sketch, give the thickness here, whatever the dimensions required. So at the upper side we'll use the 2 mm, 2.5 mm and overall wall thickness will be the 2 mm. Or we'll use the 1.5 mm overall wall thickness. After then we'll use the draft command here and we'll add the neutral elements. Then pulling direction should be in the Z direction. The pulling direction, it means the tooling direction normally. So this first rib is get completed. Let's will revolve this into the number of a patterns. So we'll add the 12 numbers of ribs here with the complete crown. Select the reference element and here the all ribs are get completed. So again we'll take a reference. We'll take a reference of a base cylinder, paste special as a result with link, and we'll add the wall thickness 2.2 mm here, and after then intersection with respect to the cylinder. So this internal ribs or external ribs are get completed by using the base cylinder. So just here. New body, select the plane and we'll start for the new outlet design. So we'll just take a rough shape of that outlet and after then we'll confirm the dimensions from the drawing. So normal to the plane. Here we'll add the basic dimensions or a basic shape. We need to close that particular body, but before that we'll add the dimensions. So this dimensions is already mentioned on a drawing. So this is the 35 mm. This is the 30. Oh, it is the just at the center of that cylinder. So this is again 12 mm. So this height is already given 110. Let's confirm from the drawing. So here is the 110 from the center, and we'll firstly we'll join this, and now it's the part of a design of the notch. So once again, that notch is common for all the outlets. So this, the radius is 2 mm, that means diameter is 4 mm. This is the 7 mm away from the top edge. This angle is of a 30 degree and is exactly tangential to the radius or that notch diameter. So the 2 mm overall, this we need to add, that particular joint we need to fill, and here the basic notch is get completed. Now with the previous practice, again we'll convert this into the solid by using the shaft command. So here we already having the three outlets body. We had given the three outlets as a name here, and the first outlet is get completed, horizontal outlet get completed, and as usual practice we will pattern this. So we are using the circular pattern command here. Complete con, select the give the instances and select the circular reference element here, and here we'll get a 120-degree pattern, three outlets horizontally. So here the basic solid, we started from the surfaces and we converted all the surfaces into the solid, and the three on four outlets in the solid commands, and now we'll add all those three bodies into a single cover body. So for that we're using the boolean operations here. So we'll finish some basic operations like giving the radiuses at the sharp corners, design sharp corners, because few of the sharp corners were required uh, for getting the internal volume. So here the sharp corners are get converted into the radius, which is already given. So now these three locators we are going to add, and this step is most important. The dimensions already shown. So let's insert into the, we'll take a new body. So now we are going to design that three locators here. For that I had taken one new plane. Select the plane, give the orientation as per your requirement, and let's will try to design the one locator, and after then we'll use the pattern command. So all the three mounting points are having the center distance 130 degree from the center. Then it means the radially it is almost of a 65 mm, and the spacing, angular spacing is 120 degree. So we'll start for designing the sketching the locating or a mounting point. So this is the basic sketch. There is a hole of a 6.5 mm diameter. So we'll see in the drawing. So there is a detail view C. So you can see 6.5 mm is a hole and the outer diameter is a 15 mm. So from that 6.5, normally this is nothing but used for M6, and the center point is just coincide on the dotted line or a center line uh, which having the diameter of a 65, radius of a 65. So it means this locating center point is away 65 mm from the center. So this flange is just we need to coincide that point on our base circle, or a or our it is just coincide on our cylinder, and this angle is a 65 30 degree. So here sketches get completed. Let will use the will erase unnecessary part. So here the sketches get completed, and in the same sketch, without exiting the workbench, in the same sketch we are adding that particular bottom side flange here. So this is also, we can see that 5 mm, 2.5 mm that mounting thickness, and 5 mm that bottom side flange thickness, and the diameter is a 115. So we'll get output the cylinder or that circular circle sketch from the original sketch. So here we don't have any reference with the mounting point or a mounting sketch. So we'll use the new body here, that is the mounting point or a mountings, and we'll use the pad command here for 2.5 mm thickness upside, and you can see the first pad is get completed, or first mounting is get completed. Same way we'll use the pattern command here for the complete crown here, and 120-degree angular spacing between that. And now here we need to add that bottom side flange of a 5 mm thickness. So all the features like a multi-outlet, then ribs and bottom side flanges mountings, all we designed here. So we need to add all those part into the final cover body. So we are using so for that we are using the boolean operation similarly for, but we'll add this as a rib. Okay, we'll rename that as a rib. So we'll add rib and mountings into the cover. So here um, the outer bodies get completed. So we'll add a radius here. Oh, so draft is missed here, so that we'll use the uh, draft command and 0.5 degree for that basic cylinder. We already covered that draft into the surfacing, and thus remaining part we did into the solid, so that the draft analysis or a draft uh, addition of a draft defining the draft definition is need to be done. So here draft we already given. Now the outer bodies get almost completed. Some of a few features we need to add like radiuses, so just follow here. So we are adding the fillets to the all sharp corners. So select all the sharp edges. So 0.1 mm is not possible, so let's reduce that as a 0.5 here. The basic radiuses or fillets we did. Okay. So radius is most important because such kind of a sharp edges are very difficult uh, during the injection molding, or a once we need to do the draft analysis. Those will be help to eject the part practically also and in design also from the from the tool. So I will just save this one. Okay, so this outer bodies get completed. Now let's moving towards the internal volume removal. So for that I will take a reference of a base cylinder. Just I will do the copy here, and I will just paste as a result with link. After then we'll add the required thickness. So in the drawing the thickness is 2 mm, 2.5 mm. So you can see here the overall thickness is a 2.5. So let's give as a minus 2.5 thickness. So this is nothing but the internal body. Once we remove this internal body, we'll get a uniform wall thickness. So let's moving towards design. The uh, internal removal bodies of a multi outlets. Because of that notch were not taken uh, directly reference from first or a basic design what we did. So instead of that, we'll take a reference of the sketch and we'll design the internal bodies or a removal body. If we are taking the reference of a that three multi outlets we designed, uh, but there is a notch, that's why we are not using that minus thickness here, and instead of that we are designing the separate removal body or a internal removal for the multi outlets. So here the 2.5 mm wall thickness is get controlled. So as usual, we are using the shaft command here, and that marked body is nothing but an internal volume. For getting out this particular uh, part from the injection molding or a tool, we need to add the minus draft here. So 0.25 draft we added. Same way, we need to design for horizontal three outlets. So here we are going to take a reference uh, of a outer bodies of three multi outlets, and the 2.5 mm thickness will maintain from here. So now as usual we are using the shaft command, and after then we'll use the pattern which are 120-degree spacing, having the angular spacing 120-degree. The draft is missed, so we'll add the draft, and after then we'll use the pattern command. Circular pattern, instances and complete cone. So crown is already selected, so the three outlets internal volume is here. We'll name it as internal. We'll add all internal bodies into the one body. So this is the final cover. So multi cover, multi outlet cover. Firstly we'll add. So this body we need to add into the outer. Yes, so we had forgot it. This is not necessary. So cover, we'll give the color here to understand, simple understanding. So internal and external is here. So for external we'll, this is the internal cover, and for the outer body we had used green color. So we'll add radiuses here to the internal. So maybe the question is there, that radius is that we just given one radius at the internal body, which is going to be removed from the outer body. uh, is it possible to get into the final product? Because maybe that is the undercut into the actual um, actual tooling point of view. If you are thinking that will be the undercut, so maybe it will not able to achieve, but in this current design, because we are just focusing on a design, we'll add this to here, but in actual it is not necessary. because it will be create a undercut here, and it is not possible. Maybe it is very difficult to add the sliders and lifter to achieve this, because it is not necessary. So it is not purposeful. So we are doing the boolean operations here, and finally we got the final product. So in this video I'm going to introduce you with a draft analysis. What is the draft angle, why it is important, and the tooling direction. So firstly we'll enter into the uh, how the draft analysis will be taken. So just select the draft direction is important, and here we have the Z direction is a draft direction. So this is the component having the multi outlets, okay, and this is under the category of a complex component. So tool is also having the complexity, and for that the slider lifters are going to be used. So this we can see that the portion which having a Z direction as a tooling direction, and you can see here. So for this some of outlets for outlet design, sliders and lifters are required. In the next video we will continue this one. So here the final product is get completed. Today's video is get completed. Thank you for watching our YouTube channel. We'll try to share more and more technical knowledge related to the plastic product design and Advance CATIA. But before that, you have to subscribe, like and share our videos, and do not forget to hit the bell icon. Thank you guys.